Hi guys, welcome back. We're back to another session. Live questions. Already, we've been doing these previous year questions on different subjects. Yesterday's choice of yours is machines, right? Electrical machines. So people are asking for synchronous machines. So I have come up with some interesting questions and analysis on synchronous machines. And today's special is, careful guys, everybody who is live, careful. Today's there is a special, something special for one person. Okay, so we have a job opening. As I said, right, I've been saying from last couple of days, recruiters are contacting us for right student. Okay, so on 18th of this month, Monday, we will be setting up an interview for one person. Core job, most likely will get that job. You can crack the job. Okay, so you need to I'll be selecting one person from this live session based on your answers. If you're answering nicely, if you're answering quickly, then you will get the eligible. I'll be sending you for an interview for one person. Okay, and most likely you will come up with the job for sure. I will train you for that job also as soon as possible. Okay, so let me tell you the criteria for this. Okay, first thing is you must be a pass out student 2023 or 2022. Either you must be 2023 or 2022 pass out student. Okay, it should be from ECE or triple E. 2023 2022 pass out students, ECE triple E. Okay, and you must be having CGPA greater than 70% of your BTech must be having this much percentage. Are you following? So if you fulfill these requirements, job of core company, yes, it's a core company, 4 to 5 lakhs package, 4 to 5 lakhs package per annum. Okay, 4 to 5 lakhs per annum. So guys, get ready. One of you will be coming out of that interview with that job for sure. Are you all ready to grab this opportunity? Tell me in the chat. I am not eligible 2014 pass out. Sorry, dear. Right now, I cannot reveal the company or anything. I'll be selecting. I'm saying, right, it's a core company, 4 to 5 lakhs. This is the salary. So once you're selected, I'll talk to you personally. So I'll be sending you. Okay. I hope all of you are set for this challenge. And how I'll be selecting this person? I'll be selecting if you fulfill. Yeah. And one more thing, one more important thing. He or she must be, I repeat, he or she must be a PiSquare student. I mean, he or she must have purchased at least one video course. I repeat, at least one video course. He must have purchased already before 10th December. Before 10th December means today is, it's 15th December. So if you purchase now, you'll not get the eligibility. Before 10th December, if you purchase any video course from PiSquare, then you will get the eligibility. Are you getting? This is the eligibility criteria I'll be sending, and you will be, once you go there, you will come up with a job for sure. This is I've been saying this from last couple of days. I'm saying this, guys. Recruiters are contacting us for the job. Guys, get ready. Okay, so this Monday, today is Friday, next Monday you'll be having interview based on your location. It could be, we have different locations. Bhubaneswar, Okay, interview location is Bhubaneswar, Kolkata, and Hyderabad. So these three are the locations. Based on your location, I will set up an interview at any one of these three locations based on your responses, based on your location. Okay, I hope guys you're all ready for this. Sir, I'm having 7 years of power plant. Please refer me. Sorry, sir, this position, this position, I think I clearly described what people are expecting, what company are expecting this. And for that, yes, I'm biased here. I'm biased here. I want to refer PiSquare students only. PiSquare deserving students only. I am biased. I'm bluntly saying I'm biased in this. I'll only send PiSquare students. Okay, that's my requirement. Okay, this part is my requirement. Everything else is company says that. Okay, so you'll have to have at least one course purchased before 10th December. Any one video course of any cost, maybe 500 rupees course. It doesn't matter. Okay, so let's get started, guys. I think this is done. This is done. Is this clear? Any confusions on this? If this is clear, we'll jump to the session where I'll be discussing the questions. Okay. What 1 rupee course, dear? What 1 rupee course? Anyways, I think this is clear, right? This page, take a screenshot. Take a screenshot if you have any confusions or anything. I gave the requirements here. Right? This is what you're going to get, core job, and these are interview locations. Accordingly, I'll set it. Okay. Okay, then I think, sir, if possible, please explain questions based on V and inverted V. Yes, Kranti Kumar, it's a synchronous machines question, so definitely we'll be having questions on that because that's one of the important topics of synchronous machines. V and inverted V curves. This is a really beautiful concept, but very simple one. Okay. So we have a questions. With the help of that question, I'll elaborately explain all of the related questions. Okay. Yes, I think we are done with this. Done with this announcement. No, dear, sorry. This thing only. Don't ask me any other questions. Here, when you're asking any other question itself, you're disqualified directly. I'll disqualify you directly. I've given everything clearly. If you don't know how to read it, you're not eligible at all in the first go. You're not going to get a place. Okay. So I written everything here. Again, when you're asking, this is, am I eligible or not? So that's not going to work, right? Right now, it's not eligible. Maybe for the next session, maybe you are. Okay. So you don't have to worry about it. We are having, people are approaching us for these people, right students. Okay. Good students, well-trained students. Okay. So you will get a position, if not today, maybe the next in the next session. And they must be BTech. These are BTech. It's BTech based. Okay. So if you are MTech, next will come up for you also. Okay. Okay, guys. Anyways, let's now get to the first question. Are you all ready for the first question? I want to hear from you guys. Are you all ready for the first question? Come on, give it up. I'm not seeing any responses. You are all dead, huh? Yes, good. At least some people are responding. Let's get to the first question. Here you go. This is the first question. Already timer is running. So how do I select based on your responses? If you're quietly sitting and not responding, how will I select you? How will you know that you're there? If you want to know you're there, you have to have a response, right? If you don't respond, I don't really know how you are, where you are, whether you are there or not. Okay. Yes. Yes, it started already. Counter timer is running. 20 seconds left for to answer this question. Okay. Time's up. So we got mixed answers. I don't know how come the answers are so mixed. Your time's up, boys and girls. It's time to check it out. The result. Let me see. Let me see your response. Okay, fine. Okay. Yeah. So what is this? What is the question is all about? The question is all about you have a three-phase alternator. You have a three-phase alternator delivering its rated current at rated terminal voltage. Okay. Wow. The first question itself, that's what Kranti Kumari is trying to ask. Kranti Kumari is trying to ask the same question, right? V and inverted V curves, questions based on that. So first question itself is that, and without V inverted V curves, don't dare to, without having understanding of V inverted V curves, don't dare to sit any exam. Okay, that's one of the popular questions. Out of 5 exams, you can expect this question, V inverted V concept questions, in at least 3 exams. Okay, yeah. I think that is also given why CRGO still is not used in other machines. In materials topic also I discussed. Good question, by the way. The thinking process itself is very good by Raju. I think those who know already, you may answer it. Okay, those who are PiSquare students who can answer this question, I think. Anyways, in material science also I discussed about this. Yeah, we have a rated current and rated terminal voltage. Power factor is 0.8 lagging. First of all, it is a three-phase alternator. In case of a three-phase alternator, this is a field current IF. This is a field current IF. Power factor, tell me, power factor curve is a V curve or inverted V curve? Come on. V curve or inverted V curve if it is a power factor? I want to hear it from you guys. See, you respond more, you'll get a better chance to get that opportunity. As simple as that. It's simple. There is no other secret because I can only see, I don't know all of you, right? I can only see your responses. If you're not responding, you're dead. That's it. Good. Madhuteja inverted V. Praveen is saying V wrong. Shravan is saying inverted V. Okay, inverted V curves. Yes, it is true. Simple, guys. How to remember this? Tell me, this is simple to answer even. Tell me one thing. Tell me one thing. I want your answer here. What is the highest power factor value? What is the highest power factor value you can get? Tell me. I want to hear from you. What is the highest power factor value? Wow. Madhu Teja is said already answer. What is the highest power factor value? Yes, it cannot be more than 1. Highest power factor value cannot be more than 1. It is as simple as that. Okay. So power factor is always less than 1. Suppose if I consider the value to be this curve to be V curve, if I consider this to be V curve, so if I start this one as 1, power factor is greater than 1. That's not true, right? So simple to even remember also, power factor 1 is here. That happens at only one field current, means the curve is inverted V curve. Simple logic, which is also given by Madhu Teja and a lot of other people. Okay, it's good. Govind has said, Tarun has said, Shashivardhan has said, Pramila has said, very good. Every one of you said. Okay, so this is the curve. Now, this power factor, where it is unity, tell me this excitation, because I'm explaining this in details just because of one reason here. I'm explaining this because in detail because of one reason. The reason is this is an important concept altogether. I want everybody to respond for this also. Tell me, at the power factor where it is unity, the field current at which the power factor is unity, what is this excitation called? This excitation is called as what? This particular excitation is termed or named as or labeled as, wow, Naveen is the first guy to answer. Raju is the next guy to answer. Great. Others? Normal excitation, Madhu Teja, Shravan. Normal excitation, Aishwarya. Nice. Every one of you right. So if the excitation here, if it is matching to unity, this is called as normal excitation. Guys, careful. Guys, careful. This curve at a specific load current, this is a curve. Suppose if the load current increases, if the load current increases, then this curve, I'm giving 4 options. This curve will shift down, shift up, shift right, shift left. What is your answer? Left, leave the left. Up, down, right. If load current changes, what is your answer? Yes, it shifts to right. Of course, that depends on the load current. Existing load current may be left or right. I am not given the left option. A few more details are required whether you want to know whether it is right or left. Okay. So this is a change. Of course, when it is increasing, I'm saying increase, right? Increase in the armature current, so it will be right shift only. Means, tell me the normal excitation for this black load current. Normal excitation is, this is normal excitation. Understood? Understood. Anyways, if I just come back, this is normal excitation. This particular point itself is a normal excitation, above which it is called as OE. What is OE? Not OG, Power Star Pawan Kalyan movie. No, not OG. OE. What is OE? Hungry Cheetah. Yes, tell me, what is OE? OE means it is overexcitation. It is overexcitation. This is underexcitation. This entire thing is overexcitation. This entire thing is underexcitation. Now, careful this point. Keep this point. Synchronous machine, beat a motor, beat a generator, it doesn't really matter. Synchronous machine, overexcited synchronous machine always delivers Q. Overexcited synchronous machine, beat a motor or a generator, it always delivers Q. Underexcited synchronous machine, it always absorbs Q. It is not delivering, it consumes, it absorbs Q. Okay, it is delivering, it is absorbing. Okay, it needs. And here, little bit, it is true for this diagram, whatever you see, it is true, beat a motor, beat a generator. I mean, beat a synchronous motor, beat a synchronous generator. Now, if it is a motor, I want to hear from you again. Guys, I want to hear it from you. If it is a motor, synchronous motor, here power factories, come on, power factories. Yes, power factories leading if it is a motor. Keep one point in your mind. Overexcited synchronous motor, no load overexcited synchronous motor is used as a synchronous condenser for power factor improvement. If you keep just bloody this line, everything on this V inverted V curve will be amazing. So if this is a inverted V curve will be with respect to IF and IA. Once inverted V, if you analyze it, V curve is with respect to IA and IF. That can be analyzed pretty easily. Okay. Great guys, great going, great going. Now, if it is a synchronous, everybody answered leading, amazing guys, very good. Now, if it is a synchronous alternator, synchronous generator, under overexcitation, what will happen? Under overexcitation, power factor is lagging or leading? Power factor is lagging or leading under overexcitation? Yes? Chitty chat. Give it in the chat. It is? No. Not a leading, lagging power factor. Okay. Overexcited, that's the only change. Everything else is fixed. Power factor is lagging if it is this. Power factor is leading if it is motor. See, up to this, whatever I said, if you can understand that properly, wow, I answered before. Okay, Gadi, okay, buddy, okay, Madhu. Yes, lagging power factor, you answered it. Very good. So, if you understand whatever I said so far, right from the beginning to this, then I'm pretty sure you'll be able to answer any question based on V and inverted V curve. Whenever there is a question on V and inverted V curve, quickly draw inverted V curve, name it as synchronous for synchronous alternator or synchronous motor, draw for one, other one will automatically get. And the same sequence I have drawn. First I have drawn this, then I have drawn NE, then OE, then Q delivered. Then everything else will follow. Okay. Now comes to this question. What it said? The power factor is 0.8 lagging. 0.8 lagging means 0.8. This is a lagging zone because it's an alternator. Lagging zone is this. Lagging zone is this. Am I right? Lagging zone is this. 0.8 means somewhere over here. 0.8 is somewhere over here. Okay. Now it is said if the power factor is changed to 0.8 leading, means somehow the operating zone from here to here it has changed. From here to here it has changed. Means what is a field current? Tell me now. I want your answer. Field current, what happened? When it is here, field current is this much. That value is taken as X or IF. That's corresponding field current is considered as X or maybe IF in this case. Now, when it comes to here, the current is less than X, whatever is given, less than X. Okay. PF is independent of source. I'm not talking about that. IF is now here. So, the field current is, the new value of field current is definitely lesser than the existing IF. Okay. I hope you understood this point. If you understood this point and you're not liking the video, then commit suicide. Okay. This is better. Okay. Anyways, we have a question. Sir, how reluctance generator unexcited? We'll talk about reluctance generator also very shortly. Then you can ask this question, Razu. Copy this question, keep it in a clipboard. You can paste it over there. Okay, good. And you are understanding the concept, but not liking. It doesn't matter whether you're liking or not liking. Okay, it doesn't matter for me. I just want to see your stupid mindset. That's it. I want to observe that only. Okay, that's fine. Do whatever you want. Your like, my pocket is not going to fill with your like. Okay. But your group-minded mentality, I'm going to get it. That's it. I'm moving to the next question. Okay, guys. Next one. Bang. Here you go. How to decide power factor is leading or lagging? Arey buddy, I told you, I think you have to watch that part very clearly, Tarun. You just watch it, you will get it. You must watch it until you get it. Okay, there are a lot more things given in there. Wow, Praveen has answered, Nanu has answered, Madhvi has answered, Razu has answered, but I don't know whether they are right or wrong. We'll have to check it out. Wow, this is an informative question. This is an informative question. But actually, 770B also available. Megawatt is also available. Yes, dear. Brahmateja, you're absolutely right. You're absolutely right. To be more precise, in India, right now, 800 megawatt. You're absolutely right. Thalia bajao Brahmateja ke liye. Just blast, send the hearts to this amazing guy, Brahmateja. Okay, who said, see, from the given options, I have no other choice. I'll have to pick 500 megawatt. But because from the old data, this question is framed, so accordingly it's 500 megawatt. But from the actual data, in the 2015 itself, I think in Karnataka, PHCL has shipped one alternator whose capacity is 800 megawatts. 800 megawatts. Yes, Saitej, you're right. Okay, that's in Karnataka by BHCL. You're right, but from the given options, so what can be done? It's a 500 megawatt. Okay. Anyways, good. Very good. Brahmateja, you're amazing. Next question. Shall we go to the next question? Are you all ready for the next question? Give it up for the next question. Give it up for the next question. Yes. Here you go. Yes, Tarun. In the question it is said, load current, load and terminal voltage, everything else is constant. Only power factor has changed. If you read the question, that line is there. Okay, Tarun. You just go back. I think you'll get clarity. You don't go back now because you may miss the chance for the interview. Okay. So yeah, you can check it out later. It's clearly explained. If still you have any question, you can leave in the comment. We can see that. Okay, nothing to worry. You got 10 more seconds left. Naveen is responding nicely. Madhuteja is responding nicely. Brahmateja is responding nicely. Madhavi is also responding nicely. Guys, I hope those names, what I taken, you have already taken the course at PiSquare. You know, if you're taken, amazing, you're going to get. It's not, it's a stroboscope. It's a stroboscopic effect, stroboscope. Okay. So in the question it is said stroboscope. I'm just checking out. Okay. Yes. Stroboscope is also one thing to determine rotary speed and vibrations. Okay. So it is a stroboscope. As well as synchroscope is also there, one other thing. But here it is about the stroboscope. What's the purpose of this? Anyways, time's up. The purpose of this in case of synchronous generator, of course, synchroscope also. Synchroscope is based on, it's a old technology. Synchroscope is not nowadays one, it's earlier one. Where pointer is there, synchroscope, I think in our class also we have seen. Okay. Stroboscope is advanced instrument to find out the synchronism, of synchronous generators, to synchronize synchronous generators. Okay. With the advanced technology. Okay, you can Google it for the details of it. Okay, I just gave the question. Yes, synchroscope, that pointer is there. It is moving like this or anti-clockwise, clockwise, all these things. It's an earlier business. Nowadays, they are becoming a little advanced. Okay. Oh, Tarun is saying, we are using in my plant. Which one? Which one you are using, dear? Synchroscope for? Synchroscope, if it is an old plant, people still use the synchroscopes only. Anyways, moving to the next question. Here you go. I think this one everybody will be able to answer it. Vibration checking, synchronized. Bright lamp method. Wow, good. It's a very old one. But amazing concept, Madhuteja. Bright lamp method, 3 bright lamp method, or 2 bright, 1 dark lamp method. You're right. It's a transducer. Good. Mostly people are saying A. Okay. Okay. I think it's an easy one. Let's not take too much of time for this. See, here, let's understand the concept also, some of the concepts also here, not just question to answer, not just question to answer. The rated voltage of alternators used in power station is usually, it is 11 kV. It's not that strictly 11 kV. Sometimes some plants will have 12.5 kilovolts. Sometimes some plants will have 14 kilovolts, something like that. Okay. Yes, it is also measured to use a speed measurement also. So 11K is more or less, yes, this is a value of, this is the question in interviews also people ask. What's a generated voltage in the power plants? So it is something close to 11 kilovolts. Now the question is, why you are limiting this generated voltage to 11 kilovolts? Why can't you generate 33 kilovolts? Because if you increase the voltage for the same capacity of power, current will be less, losses will be less, copper size will be less. But still, why you're limiting your voltage to 11 kilovolts? Why not beyond 11 kilovolts? Wow, man, that's wow. Most people have answered it. Very good, very good. Yes, you can increase voltage to 33 kilovolts also, but insulation is one of the key aspects. If it is a current, copper conductor is there, that will nicely carry the current, it's okay. But when it comes to insulation, you see, a tower, transmission line towers, you're having two conductors spaced too distantly. Some meters distance is there between two conductors, because when you're increasing the voltage, insulation is one of the biggest problems. That's the reason why in underground cables will not go for high voltage also. Even for 66 kilovolts also, you'll have to have a lot of cooling aspects, insulation to protect the insulation. You'll have to take a lot of measures for the underground cables also. But if it is a machine, the size will be even huge. It is completely uneconomical if you generate the voltage at high voltages because of the insulation problems. All of you nailed it. Okay, all of you nailed it, simply nailed it. Yes. Insulation plays, yes, you're right, guys. Yes, you're right. Even for 66 kilovolts, when you're going to that level of voltages in underground cables, you have to pump the oil. It's not a regular cables. It's oil-filled cables or gas-filled cables. Okay? Anyways, that's good. Amazing. So, answer is 11 kV. It's not that. It's not just you have to know, about 11 kV. Why it is that? You should search that. Okay, in the exam you can't do it, but in the practice you should be able to do all of these. Move to the next question. Guys, I think you have to actively participate. You have to actively participate, at least those who are having that eligibility criteria. Okay, those who are having that eligibility criteria for the job. Okay, you are going to I'll be sending some people to the interview, one person at least to the interview. Madhvi, Brahmteja, Praveen, Shravan, Naveen, Nanu. Nice. People have answered it. Everybody's saying A. Is it an easy question? Oh, come on. It's an easy question. Let's not waste much of time on this. Cylindrical rotor alternator have. We know cylindrical alternator rotor number of poles are limited to maybe 2 poles. Maximum 6 poles you can have. Maximum 6 poles. 2 to 6 poles you can have. If it is salient pole machine, then you can go up to 2 to 32 poles you can have. So to accommodate such huge number of poles, the diameter of the salient pole machine diameter is huge and axial length is less. It is the other way for a cylindrical or non-salient pole. So length is high, axial length, it's lengthy. The diameter is thin. It is lengthy for the same power capacity. So larger the diameter, smaller the diameter, axial length is high. So large length to diameter ratio, yes, L by D ratio is overall it is large. So I think for the first time in this session to happen, everyone answered correctly. 100%. Oh no, some people answered C as well. Okay, sometimes it happens. What to do? Yes, man. Govind, you're right. For high speed, tell me. I want to hear it from everyone. Everyone. Okay. High speed one is, what is a high speed machine? For high speeds, which one you will use? Cylindrical or salient pole? For high speed, yes, come on. Wow, Madhu has already answered it. He is smarter. Cylindrical rotor is also called as a turbocharger. You are using right, a turbocharger, VOOC charger. What is the super VOOC charger? What is this turbocharger? High speed charging. Turbo alternator, high speed alternator. Very good, Madhu Teja. Wow, Brahmateja and Madhuteja, they're competing with each other. Amazing competition. They are usually used in thermal and nuclear power plants, high speed ones. Low speed ones are used in, yes, silent pole, they are used in hydro power plants. Amazing, guys. What a sportive spirit. Superb. Now, let's get to the next question. Okay. And this is clear? I am moving to the next question. Here you go. Turbochargers used in DC sets. Turbochargers, turbo alternators. Brahmateja, Madhuteja, Madhvi, nice, loved it. See how quickly they answered this question. Of course, it's a numerical question, yet we got a quick answers from Brahmateja and Madhuteja and Madhvi, as well as Raju. So first three, if I count it, it is Brahmateja and Madhuteja, but I don't know, they related the responses. What happened? Okay, so it's a 4-pole machine. Madhvi, you said it is 1000. Check your answer here. It's a 4-pole turbo generator, 50 hertz. Guys, come on. You should keep these numbers as a pair. 50 hertz, 4-pole means 1500 RPM. That's it. This is a combo. With the practice, we'll have this. NS is equal to 120 F by P. This is a P50. This is a 4. Here 30 times. This is 1500. Of course, it's an easy math to do. But I don't expect my students to be doing this kind of stuff, because 54, 1500 is a pair. You should pair them up. Okay, if any two is asked, another one you should be able to easily say. I'll ask a similar question. Let's see who will answer this question quickly. Get ready, guys. Get ready with your fingers. Get ready on the chat. Tell me, 0.8 power factor means what is a power factor angle? What is a power factor angle if it is a 0.8 power factor? Come on, I want to see the answer from you. Without calculator, tell me. Wow, Madhudeda said 3000, 1500, 750. Wow, good. Raju, Krantikumar, Shravan, Madhuteja, amazing guys. Nanu, Tarun, good. So these things should be at your fingertips. At any time, you should be able to, deal with this. Anyways, anyways, let's get to our business, where we will be talking about now. So this answer is 1500 RPM. Shall I go to the next question? Next question. Are you guys ready? Bang. Oh, wow, wow. Look at Madhu, what he said. He sent a sequence earlier. Sequence says something like, in the early chart, 3000, 1500, 1000, 750. That's amazing. Two pole, four pole, six pole. And yeah, in that way, yes, that's a good one. A really good one. If it is six pole, it is 1000 RPM. At least if you have that figure, at least 54 and 1500, that will be pretty much good. If not all. If you keep all, that's amazing. This is a conceptual question, an easy question. Let's see who's going to answer this. 5 more seconds. What happened? Such a poor response. Such a poor response. What happened, guys? Huh? For such a simple questions, if you don't have a good response, such a conceptual questions, then what can I do? Who has answered correctly? Who has answered correctly? Nanu has answered correctly. Sampath has answered correctly. Avinash, Krantikumar. After saturation, there is no response, sir. Brahmteja, no, man. You're missing. You're missing the concept. Okay, let me explain this. As most of the people are committing a mistake on this question, let me take time to explain this quickly. Quickly. In a three-phase alternator, come on here. Draw, all of you. Those who are giving answer except C. All of you draw synchronous impedance method. When you are finding out the voltage regulation by synchronous impedance method, okay, with respect to IF, when you're drawing a ZS, not with respect to IS, with respect to IA, when you're drawing ZS, what is a curve? ZS, how the ZS will change with respect to IA when you're changing? It is ZS synchronous impedance. Synchronous impedance is like this, like this, like this, and slowly it will go like this. Synchronous impedance goes like this. This is unsaturated once the core sets into saturation because of the armature reaction. So this goes down, synchronous impedance goes down. Okay, so if this value is 3, I think this is what a fundamental thing. For EMF method of voltage regulation, this is a curve you'll be drawing, right? So impedance, here it is 3 ohms. Under the this is unsaturated. Once its saturation sets in, synchronous reactance, synchronous impedance, because synchronous reactance comes down and the synchronous impedance comes down. So after the saturation, during this zone, the value is less than here. So this value is 3. So this value is less than 3 ohms. Simple. Pretty simple. Okay. I hope it is clear. I hope it is clear. Come on, give it a thumbs up. Give it a thumbs up if it is clear. Now, quickly, let me take you to the offer. Let me just give you the details of the offer. Okay, in today's session, I said there is a job opening. There is a job opening, direct interview. I mean, with a basic written test and interview. That everything I will take care of it. Nothing to worry. On 18th, you must be either 2023 or 2022 pass out BTech, either from EC or Triple E with greater than 70%. This is one thing. And another thing is, package is, it's a core company, 4 to 5 lakhs per annum. And interview locations are Bhubaneswar, Kolkata, and Hyderabad. Based on your location, I'll tell you. And another criteria is you must be an existing PiSquare user. Strictly, you must be an existing PiSquare user. What is meant by existing PiSquare user? Before 10th December of 2023, today is 15th, before 10th December, you must have purchased already at least one video course from PiSquare Academy. If you meet all eligibility criteria in the chat now, I am going to select one person, okay, from the responses what you have given so far, okay. ZPF is pessimistic method and MMF method is optimistic method, not ZPF dear, not ZPF, it is EMF method is a pessimistic method, MMF method is optimistic method, okay. Anyways, so this is what the criteria, okay. So you will, if you are feeling that you are looking for a job, nice core job with nice package, you'll be getting it, okay. Get ready. We're at the last question. I think we are done with 7 questions. Okay, a few more questions are there. After that, I'll select one person from you. Among you, one person will be getting this chance. Get ready, guys. Boys and girls, get ready for it. Yeah, I'm saying right. Last one you're missing. I already said I just take care of my students, deserving student obviously. PiSquare students is my priority. That's the reason why I kept that, because obviously I want to benefit my students, right? This easy question, I think. Gate timetable. Anyways, see, don't think that if you miss this, next one you may not get. Next, I'm saying it right. We are having, uh, recruiters are reaching out to us. Right now, I'm announcing publicly, but earlier what we used to do is we used to take the best performing candidate from the our test history and all. So we used to send those resumes to the people, okay. But now the numbers are high. Numbers are high. People are asking for almost, I think a good number of vacancies are there from different companies. So yeah, that's why I had to announce it publicly so that to get the right persons. Okay. Yeah, follow the channel. I think link is also given in the description. WhatsApp channel, you follow it, or maybe you can follow our app. There you'll get the updates, and then the live also. Anyways, yeah. Let's come to this. Question. The question is: under short circuit condition, the power factor of an alternator is. Come on, yeah. We know this thing. In case of an alternator, you have equivalent circuit diagram. Equivalent circuit diagram. This is the equivalent circuit diagram of an alternator. This is the terminal voltage. RA, XAL, and XAR, armature reaction and leakage reactance and armature resistance. And for almost any alternator, you can pretty much ignore this resistance. The value will be pretty much less. And compared to these two combined it is XS. Now, I want you to respond in the chat. I want everybody to respond in the chat. Out of these two, as in out of XL and XAR, which one is greater? What's the relation between XAR and XAL? What's the relation? Yeah, go ahead. What's the relation? Yes, there is synchronous impedance. Among these two, what's the relation? Which one is greater, which one is less out of these two? Wow, very good, Shravan. Very good. Brahmateja is saying demagnetized. XAR is high. Very good, Tarun. Any other? Okay, that's it. I think everybody answered pretty much good. Okay. So RA, I can pretty much ignore this because it's very small. I can ignore this. So if I ignore this, the moment I short circuit this, it's like this is purely driving the inductance. The current is naturally lagging almost 90 degrees. Current is lagging almost 90 degrees because this is almost inductive. Less resistance. Clear? Okay. Then it is not 0.6 lagging. It is a 0 power factor, almost 0 power factor. Almost 0 power factor lagging. And amazingly, Brahmateja is saying also something. It is the effect is demagnetizing effect. The effect is demagnetizing effect. Careful and clap for Brahmateja because this point, this analysis is going to help you in the next question. You have to do such kind of analysis. When you're practicing, don't try to limit yourself to what just asked in the question. You expand a little bit. Again, during the practice, that's why your mind will be trained enough. Whenever you see this short circuited, you will immediately recall, okay, it's almost 0 power factor lagging, means it is a demagnetizing effect. If it is a demagnetizing effect, short circuit current is limited, means it is still in the saturation zone. So that's why always short circuit characteristics is linear. Wow. All these things just with the point what he mentioned, Brahmateja mentioned. Okay. So you have to be sharp like this. You have to expand your brain. Okay. Yes. We got just few more questions. After that, I think one person will be selecting one person ASAP. Okay. Yeah. Twenty seconds left. Okay, guys. Time's up. So synchronous here, the analysis. Answer, of course, most of you know, but the analysis. Analysis is a key aspect. Focus on the analysis, what we're going to see. The synchronous impedance of a large size modern alternator is about, usually, synchronous impedance means we just draw the circuit. We have this, this is XS, this is RA, this is EF. So you're connecting a load here. So basically, this is like internal impedance of the source. Z internal impedance. In general, with the concept of network analysis, what you know, I want your response, guys. With the basic understanding of the networks, what you know, internal resistance of the source must be high or low. Internal resistance or internal impedance of the source must be low or high. It must be low. It must be low. So if I consider this one as a source, practical voltage source, means voltage source with a series impedance, Now, we know, ideally speaking, this input impedance must be 0, which everybody knows. It must be 0. It is like a input impedance, internal impedance, not input impedance, internal impedance. So accordingly, it should be about, ideally it should be 0. Maybe it's a 0.1. It appears to be like that. Rather, earlier days, it was like that. But nowadays, modern alternators are designed to have high internal impedance, means high this value. Anyways, this is less, this value, they are maintaining a high as almost 1 per unit. Now the question is, why? What is the question? Question is, why? কেন? কি করছো? কেন করছি? Why? Wow, Kranti Kumar, wow, for Madhu Teja and High Current, Sanjeev, wow, just wow, guys, just wow. So what your friends are saying is, it's not I'm saying, your friends are saying, I'm just repeating that point. Absolutely right, what your friends are saying, to limit the short circuit current. SCR, not South Central Railway or Silicon Control Rectifier. Short circuit ratio, short circuit current ratio. Okay, SCR, short circuit ratio, one will call. That short circuit ratio means when it is under the fault, if it is short circuited, if this internal impedance or ZS is low, huge current will drive, it will drive huge current. Now this high impedance will maintain under the fault currents also, under the faulty conditions also, the current will not be so high. Okay, it will limit the current. Most of you answered it correctly. Okay, most of you answered it correctly. So for modern alternators, it is 1. It is 1. Good Madhuteja, Brahmateja, Tarun. 3 of you, amazing job. Kranti Kumar, yeah, also. Kranti Kumar also. Next question. Wow, look at this. 15 more seconds. Low, whatever possible with us. Okay, so it is asking about the ratio of armature leakage reactance to synchronous leakage reactance. Usually large size alternators is usually about, what will be the value? When you say low, it is 0.05 is another one is there, right? It's not what should be, what is usually. Usual number is how much? We have seen, I think somebody said rightly, RA value is very less, XAL is somewhat higher, XAR is much higher. So if you take a ratio, it will be XAL by XAR or XS. This ratio, what is asked? Yeah, this ratio will be not 2. Yes, Madhuteja, Tarun. You're right. Okay. So I'm just ending the session for the sake of time. I'm ending the session over here because 1 hour session is over. Now, guys, I'm coming to the final. I selected few people based on your chat responses. Okay. I want all of you, first one, I want you to type your 4-digit phone number. Tarun, Brahmteja, Tarun, and 3 people, Madhuteja. Or 2 Tejas are there. So, based on your responses, guys, don't worry, others also will get a chance. This chance is right now chance, maybe others may get a better chance. Okay, maybe in the next session also. So don't worry about anything. Okay, I'm here. So right now, these are the 3 people. On these 3 people, out of these 3, I don't know how many. I'll select only one person. Based on the criteria. I'll select the criteria, whether they're a pass out or whatever it is. Based on the criteria, I'll be selecting one person out of these. Okay, so I want you to give your 4-digit number. If you feel you are qualified, you have all the eligibility, what I said. All of you, are you present first? Are you present, guys? Let's give it to Krantikumar also. Krantikumar also responding nicely. Krantikumar Gaud. It is 5410. If you are not eligible, you tell me, sir, I'm not eligible. I mean, you're not into the eligible category. Then we'll not spend our time on you also, okay? Krantikumar? Oh, Tarun, in that case, it's not possible, dear. So, Tarun, Krantikumar, if you are falling into that eligibility criteria, you can give your 4-digit number. Krantikumar Gaud. Oh, not eligible? Okay. Brahmteja and Madhuteja, you are from which place? I mean, you are near to Bhubaneswar, Kolkata, or Hyderabad. Which one? Bhubaneswar is good because it's near to me. Kolkata also fine. Hyderabad, any place is fine. You are from which place? Tell me. You are from which place? Both are from Hyderabad, Andhra Pradesh. Hyderabad. Okay, guys. Among these 2, I'll be sending only one person. I'll talk to you personally. Then I'll select one of you. Okay, if both are, because both of you are competitive and nicely participating in the responses, so I'll try to send both of you if time permits. I mean, if situations, if you are really talented, I'll definitely encourage both of you to. I'll try to send both of you, and I want you to take a screenshot of the image what you see now. Just take a screenshot of it and WhatsApp. Just send a WhatsApp of the screenshot from the same registered number. Then our team will follow up you. Okay, guys. Okay, congrats for these 2 people, Madhuteja and Brahmteja. तालियां बजाओ भाई इसके लिए. At least like for these people who got, congratulate them, spread your love, and we'll be waiting for your turn in the next. Okay, next one is yours, guys. All the best. And definitely, I recommend you to follow our WhatsApp channel. You follow it. And you know, right, already PiSquare style, you know already. I don't have to say what is the PiSquare style. Okay, you know it. And if you want to buy any courses from PiSquare, I think you can visit courses.p8.in. Okay, you can visit our website. You can check the scrolling. There you'll get amazing courses. Free content is also available. You try to watch the free content, try to learn, try to feel the beauty of engineering. Okay. Happy learning. Enjoy the learning in PiSquare style. Bye-bye.